Hello friends, welcome to Mechanical Engineering online classes. Today's lecture will be delivered by Miss Shravanti Sri Ramoju.
Sometimes because of space constraint or when a change of stiffness is needed at certain deflections, springs can be used in combinations. So there are two types of spring combinations. One is springs in series and the other is springs in parallel. So the arrangement of springs in series is shown in the figure here. There are two springs of stiffness K1 and K2. This is the spring 1 and this is spring 2, and corresponding stiffnesses are K1 and K2 respectively, which are under a load W. They are placed in series, in the sense the end of one spring is attached to the beginning of the second spring. Let us assume that W is the total load acting on the springs, total load, and let me assume that W1 is the load shared by spring 1 and W2 is the load shared by spring 2, and K1 and K2 are the stiffnesses of springs 1 and 2 respectively. And let us assume that delta 1 is the deflection of the spring 1, delta 2 is the deflection of spring 2, and delta is the total deflection of the springs in mm, and K is the combined stiffness of springs in Newton per mm. So when the springs are connected in series and total deflection of the springs delta is again equal to delta 1 plus delta 2, the deflections of both the springs combined. Now if for example K is the combined stiffness, which we have already indicated here, now if I write this particular delta as W by K, it is similar to F is equal to Kx. X is the deflection delta and K is the stiffness and W is F. So here delta is replaced by total load by combined stiffness, W by capital K, which is equal to delta 1. Corresponding equation for spring 1 will be the load shared by spring 1 divided by the stiffness of spring 1 plus load shared by spring 2 W2 divided by spring stiffness K2. One more important point to note here is when the two springs are connected in series and there is a load that is applied, as they are connected end to end and they are placed one below the other, the load shared by both the springs will be equal, in the sense W1 will be equal to W2 and that will be equal to W. So the entire load is being shared by both the springs. So here if I substitute W1 is equal to W2 in this equation, we get W by K is equal to W by K1 plus W by K2. So if I cancel out W value, I will be left out with the combined stiffness formula as 1 by K is equal to 1 by K1 plus 1 by K2. Considering the case where springs are in parallel, so it could be either of these two connections where spring 1 is attached to mass M and at the other end of mass M there is spring 2 attached, and the other kind of combination in parallel can be somewhat like this, where the two springs are placed one beside the other. They are not connected end to end, they are separately placed one beside the other and there is a load W acting upon them. So the equivalent stiffness of the springs could be assumed to be K, and we are now supposed to find out that K value. As we have already seen, total load is W and W1 and W2 are the loads shared by both the springs, K1 and K2 are the spring stiffnesses. Delta 1 and delta 2 are the deflections of springs 1 and 2, and K is the combined stiffness of the springs, and delta is the total deflection. Now W should be equal to W1 plus W2, and if you look at the deflection in both the springs should be same. So delta should be equal to delta 1. It is further equal to delta 2. The deflection in both the springs should be same because the load is acting upon both of them, and the entire system will be compressed. So the deflection in both the springs should be same. Now if we write W as, or the force as Kx, then W will be K into delta, and W1 will be equal to K1 into delta 1, and W2 will be equal to K2 into delta 2. But we already know that deflection in both the springs are always equal when they are connected in parallel. Therefore, if delta 1 and delta 2 are equal, then K delta will be equal to K1 delta plus K2 delta, and delta can be cancelled out. We will remain with the combined stiffness K equal to K1 plus K2. So it is mere summation of the stiffnesses of springs.
Thanks for watching. If this video was of help to you, please like it and share it with your friends. And don't forget to subscribe to our channel.